In this video we talk about right triangles. A right triangle is a triangle that has one square corner. So one of these corners has a 90-degree angle. Now the types of questions we will do are when you're given some information about the side lengths and the angles of that triangle, and you need to find all of the other side lengths and angles. So let's do an example where, well, first let's begin with a hypotenuse of 5. Hypotenuse is the name for that long side. Sometimes the shorter sides are called legs, and these two sides connected to the right angle have to always be shorter than the hypotenuse. Try to draw a triangle where that's not true, and you'll see you just can't do it. So let's say that hypotenuse has a length of 5, and we have a side length of 4 on the bottom. And now the question is, what are the angles? And this one as well. And what is the length of this last side? So in order to find angles and side lengths, it's nice to give it a letter so that you can put a letter on your drawing, on your sketch of the triangle, and then also show what it's equal to in your work. Usually we use these Greek letters for angles. Let's call this one alpha, and this one beta. And then let's call this side, well, let's call it S. Okay, so in order to find the side length of S, the triangle will have to obey the Pythagorean theorem, which is 4 squared plus S squared equals 5 squared. So let's just write that down. 4 squared plus S squared equals 5 squared. And we just need to solve for what S is. And this is generally what you want to do when there's something you want to find out. Try to find an equation where you can write what the variable you want to find as part of the equation, and you have numbers for everything else, so you know all the other parts of that equation. So here the only thing we don't know is S. We can solve for that by putting S on one side of the equation all by itself. We subtract 4 squared from both sides. So when we subtract 4 squared, it disappears from here and shows up on the other side with the minus sign. I could have found what the squares are first, or I could do it now. It doesn't really matter what order we do those in. Let's find what 5 squared and 4 squared is. So we have 25 minus 16, which is just 9. And now S is the square root of 9. If S squared is 9, then S has to be the square root, and we get S equals 3. So now we know what S is. Let's just put a little box around that. Okay, so this one is solved. Let's find what alpha is. Now the cosine of an angle is the adjacent side over the hypotenuse. The adjacent side to alpha is this one with side length 4. You can see this side actually makes up one of the lines that defines alpha. So this is a side length 4, and alpha is the angle between that line and the hypotenuse. So we want to pick this 4 for cosine. The hypotenuse is 5. That goes in the bottom of the fraction. So we have cos alpha equals 4 over 5. And if cos alpha is 4 over 5, that means alpha is the inverse cosine of 4 over 5. Let's just do that on a calculator to see how it's done. So we find, you see that orange text? I'm going to access that by pressing the second function button. And now when I press this button, you'll see that shows up as the inverse cosine. That -1 superscript implies that it's the inverse cosine. And that is, in the inverse cosine is where you put the ratio between the two side lengths. Now I don't just want to type 4 because I'll have to type divide as well. And, well, let me just show you what I mean. What I need is a bracket first, because I want the inverse cosine of 4 divided by 5. If I didn't use brackets, it would have just acted on the 4, and then after that divide by 5, which is a different number and the wrong answer. So it's important that 4 over 5 is in brackets in the calculator, and then we hit equals, and out comes our answer. Notice the calculator is set to degrees. There's another kind of angle called radians that are often used, and the calculator would say rad if that was the case. So you could switch to rad there, but I'm going to keep this on degrees for this video. So we have 36, let's say 0.9 degrees for alpha. So alpha equals 36.9 degrees. Now, we could find beta by using a trigonometric function. For example, sine of beta would be the opposite over the adjacent side. Or we could also use just the fact that all three angles of a triangle have to add up to 180 degrees. I think that one's a little bit simpler, so let's do it that way. But you'll see when you're solving for these right triangles that there are several different ways to get the same answer. That's actually a good way to check things. If you do it two different ways and get the same answer, then you probably got it right. So for any triangle, the three angles have to add up to 180 degrees. So we can say that alpha plus beta plus 90 degrees equals 180 degrees. And you might want to remember this just as alpha plus beta has to add up to 90 degrees. You just subtract 90 degrees from both sides, and you end up with a 90 over here. And this is true for right triangles, where one of the angles is always 90 degrees. So these other two angles have to add up to 90. We know that alpha is 36.9, so beta is just going to be 90 degrees minus alpha. Beta equals, let's do that on our calculator, 90 minus 36.9. All right, so 53.1 is our answer. 53.1 degrees. Okay, so we had alpha, and we had beta, and we found the side length S. So we found this and this and S, and we know everything about that right triangle. Okay, so let's try one more example where we're given one of the sides and one of the angles. Okay, so this time let's say we have a 45-degree angle, and we know that this side length is 10. We already know that this angle is 90 degrees, and because this and this angle have to add up to 90 as we saw above, this other angle, we already know it's going to be 45 degrees without having to do too much work to find that other one. Now the question is, what is this hypotenuse and what is this side length? And we can't use the Pythagorean theorem here because if we wrote s squared plus 10 squared equals h squared, we don't know h and we don't know s. So this time there's two things we don't know and we're not going to be able to find either of them. So we'll have to write one of our trigonometric functions so that it involves something we know and something we don't know. So, we don't want to look at s over h because we don't know s or h. But if I do cosine of this angle, cosine 45 degrees, that's going to equal the adjacent side over the hypotenuse h. And that hypotenuse h is something we need to find out. And I already know that side length, so that's why this one will work. So if we multiply both sides by h, I'll do this in a couple of steps just to make it clear how this works out. We get h cos 45 equals 10. And now divide by the cos 45. And you find h equals 10 over cos 45 degrees. And we just need to do that on the calculator. So 10 divided by cos 45. And h is about 14.14. Now that we have h, we could use the Pythagorean theorem. We could also use a different trigonometric function. Let's just do that Pythagorean theorem way again. So we have s squared plus 10 squared equals 14.14 squared. And s squared equals 14.14 squared minus 10 squared. Let's find what this is on the calculator. So 14.14 squared minus 10 squared. It's almost 100 exactly. And if we had left all of those digits in there, I think we would have gotten 100 exactly. So let's write that down, 100. Now, the reason it worked out that way is that we have a 45-degree angle. And whenever this angle is 45 degrees, you'll find that this side is actually equal to this side. So knowing that, we could have actually saved a step and just written that s equals 10. So you can remember that for next time you see a 45-degree triangle. And we see that from the Pythagorean theorem, this also works out to s equals square root of 100, or s equals 10. And there we go. We found our final side for this triangle as well.